$180,000. That was the official estimate to replace what had been deemed a catastrophic failure. The report, produced by a proprietary diagnostic program, employed frightening terms like systemic fuel contamination and irreversible injection pump seizure. It depicted a Volvo TD-100 industrial engine, a piece of machinery engineered to outlast the building it powered, as having effectively rendered itself a useless heap of scrap. In the opinion of the experts, the fuel system was utterly destroyed. But that report was mistaken. The engine was not dead. It was merely waiting for an individual who grasped the distinction between a digital error message and physical fact. This is because the gap between a six-figure replacement and a 50-cent fix often depends on one principle: knowing that electricity, unlike human beings, is incapable of deceit. Station 4 is located at the base of the drainage basin, a concrete bunker built for a single mission: to move water when gravity is not enough. Outside, the first significant rains of the season were pounding on the metal roof, a relentless rhythm announcing the arrival of flood season. Inside, the atmosphere should have been vibrating with the deafening, chest-rattling roar of the backup generator. But the room was still. The only sounds were the hum of the fluorescent fixtures and the anxious tap of Noah's boot on the concrete floor. The Volvo TD-100 is not a subtle piece of equipment. It is 10 liters of Swedish iron, a six-cylinder monument to mechanical injection technology that functioned on basic, powerful principles: compression, fuel, and air. For 3 decades, this particular machine had been the sole barrier between the municipal archives in the basement and 3 feet of silty river water. It did not require a firmware update. It had no need for a wireless connection. It simply had to work. And it had been working, right up to the moment it stopped. During the required monthly load test, just as the transfer switch flipped to simulate a power grid failure, the engine died. It did not sputter or cough. It did not emit black smoke indicating a fuel blockage or a clogged filter. It just cut out, instantly, as though an unseen hand had reached into its governor and throttled it. The abrupt void of noise was more alarming than any explosion could have been. Noah stood before the silent green giant, his hands clutching a rag that was cleaner than it ought to have been. As the facility manager, Noah knew the rhythms of this plant better than he knew his own family. He knew the TD-100. He knew that when a diesel engine stops so abruptly, without a mechanical death rattle, the issue is generally straightforward. It's typically a switch, a wire, or a valve. But Noah wasn't permitted to be straightforward. The new municipal insurance contract was explicit. Any breakdown of critical infrastructure necessitated certified diagnostics from an authorized service center. He was constrained by bureaucracy. He glanced at the rain gauge on the wall. The water level in the main intake was climbing an inch every 20 minutes. If the main grid went down during the storm, a statistical inevitability in this county with its old substations, and this generator failed to start, the pumps would remain idle. The basement would be submerged in 4 hours. The silence in the room was heavy, pressing on his eardrums. He could sense the financial pressure of the rising water, a potential disaster that would be measured in millions. He pulled his phone from his pocket. His thumb paused over the contact for the authorized dealership. He detested making this call. He knew what would follow. They would dispatch technicians who were brilliant at reading tablets, but were illiterate when it came to mechanical governors. They would regard the TD-100 as if it were a relic from the age of steam, something to be replaced instead of understood. But he had no alternative. The protocol was absolute. He made the call. Station 4. We've had a critical failure on the standby unit. Immediate dispatch is necessary. The wait felt interminable. Outside, the storm grew stronger, the sound of rain on the corrugated steel transforming into a steady roar that seemed to mock the engine's silence. Noah paced the concrete floor, his eyes tracing the fuel lines, searching for a leak, a break, anything physical. There was nothing. The engine was clean. It was dry. It was dead. When the service van finally arrived at the heavy steel doors, it looked like a spaceship next to the rust-streaked station. It was covered in bright vinyl graphics that promised next-gen power solutions. 2 technicians emerged, dodging puddles. They didn't carry heavy steel toolboxes or smell of 15W40 oil. They carried molded plastic cases and tablets shielded by rubber bumpers. They looked at the rain, then at the station, with an air of clinical detachment. To them, this wasn't a potential flood disaster. It was just ticket number 4092. Noah opened the door, letting the humid storm air mix with the stale odor of idle diesel. The clock was ticking, the water was rising, and the digital age was about to enter a mechanical world it did not comprehend. The arrival of the service team was less like a mechanical repair and more like a scene from a sterile laboratory procedure. The van doors opened with a pneumatic hiss, revealing a racked interior that contained more computing power than the station's entire control room. Two technicians emerged, their uniforms pressed and spotless, the logos on their chests stiff with new embroidery. They moved with the brisk, efficient self-assurance of men who believe that every problem can be solved with a software patch. They didn't glance at the sky, where the storm clouds were bruising the horizon. They didn't look at the water level gauge. They walked directly to the generator room, their eyes searching for a data port before they even acknowledged the machine itself. The lead technician, a man in his late 20s who introduced himself only by pointing to his badge, placed a heavy, rubber-armored case on the workbench. He didn't open a toolbox. He didn't take out a wrench, a screwdriver, or even a rag. He opened a laptop and a wireless interface module. The TD-100, a beast of cast iron and mechanical linkages, stood silently behind him, dripping with condensation from the humid room. It was a machine built in an era when diagnostics meant listening to the valve lash with a stethoscope. But 3 years ago, a municipal compliance rule had mandated a retrofit. A spiderweb of aftermarket sensors and wiring harnesses had been zip-tied over the engine's original framework, designed to translate its analog functions into digital data. The technicians ignored the physical engine completely. They didn't check the manual lift pump to feel for resistance. They didn't crack a fuel line to check for pressure. They didn't pull the dipstick to smell the oil. Instead, they hunted for the OBD2 adapter that had been spliced into the retrofit harness. When they found it, hanging loosely near the starter motor, they plugged in their dongle with a satisfying click. The laptop screen flickered on, displaying a loading bar that seemed mockingly slow, given the urgency of the rising floodwaters. "Establishing communication with the ECU," the lead tech announced, his eyes fixed on the progress bar. The second technician stood back, holding a tablet that mirrored the laptop's display, nodding as if verifying a complex calculation. They were interrogating the ghost in the machine, ignoring the corpse on the floor. Suddenly, the screen turned red. A cascade of error codes scrolled down the display, a digital indictment of the engine's health. The lead technician let out a low whistle, the kind a doctor makes when looking at a terminal X-ray. He turned the laptop so Noah could see the carnage. "Look at this," he said, tapping the glass. "Code P0087. Fuel rail pressure too low. Code P0093. Fuel system leak detected. Large leak. And here's the killer. P0088. Fuel pressure variance critical." Noah stared at the numbers. They meant nothing to him. "What does that mean in English?" he asked, his voice tight. "It means your fuel system is compromised," the technician said, his tone shifting from clinical to condescending. "The sensors are reading 0 pressure at the injection pump inlet, but the rail pressure sensor is showing erratic spikes. That's the signature of severe contamination. You've got algae, water, or sediment that has bypassed the primary filters and hit the high-pressure side." "That's impossible," Noah said, gesturing to the fuel polishing system on the wall. "We treat the fuel. We cycle it." "The data is conclusive," the technician cut him off, pointing to a jagged red line on the graph. "See that variance? That's the signature of a seized pump. You've likely hydrolocked the plungers with biofilm. It's physically fused together inside." The second technician chimed in, reading from his tablet. "According to the diagnostic tree, a variance this high with 0 inlet pressure is a catastrophic failure of the injection array. The contamination has destroyed the pump and likely blew out the injector tips. The entire high-pressure side is scrap." "So, you're saying the engine is dead?" Noah asked, the silence of the room suddenly deafening. "I'm saying it's beyond economical repair," the lead tech said, closing the laptop with a snap. "We can't fix this. You can't flush this kind of damage out. The system is toxic." Noah looked at the TD-100. It looked exactly as it had yesterday. Strong, capable, unbreakable. But the screen said it was a hollow shell, gutted by invisible algae. He wanted to argue. He wanted to tell them to pick up a wrench and prove it. But he had a rain gauge that was rising. and a graph that was red. The digital verdict was in, and in the modern world, the screen always overrules the steel. The lead technician didn't just close the laptop. He pivoted immediately to the solution, a transition so practiced it felt like part of a script. He tapped the screen again, bringing up a pre-generated PDF that looked less like a service invoice and more like a glossy marketing brochure. It was a condemnation order, standardized and sanitized, designed to make the destruction of a 30-year-old capital asset look like a prudent business decision. He turned the screen toward Noah, the blue light reflecting off the damp concrete floor, illuminating the bottom line that would bankrupt the department's maintenance budget for the next 3 years. "Here's the reality of the situation," the technician said, his voice dropping to a tone of somber professional advice. "The fuel system on this TD-100 is catastrophic. To repair it, we would need to source a remanufactured injection pump from Europe, flush the entire line set, replace all 6 injectors, and drop the tank for chemical cleaning. Parts availability for these legacy units is non-existent in our network. We're looking at months of downtime and no warranty on the work because the contamination is systemic." He swiped to the next page, revealing a bright, high-resolution image of a gleaming white generator set, enclosed in a sound-attenuated cabinet. "However," he continued, brightening, "we have a Tier 4 final compliant unit in regional stock. It's fully digital, emissions compliant, and integrates directly with your building management system. We can have the paperwork signed today." Noah looked at the numbers. The base unit was listed at $180,000. But below that, the necessary integration costs began to stack up like sandbags against a flood. $40,000 for exhaust retrofitting because the new engine ran hotter and required a different ventilation flow. $10,000 for concrete pad modification because the footprint was different. $5,000 for a new transfer switch because the digital logic wasn't compatible with the station's analog breakers. The total was nearly $250,000. "And the timeline?" Noah asked, looking at the rain sheeting against the dark window. The water outside was rising. The storm wasn't theoretical. It was knocking on the door. "If we expedite the order, we can have the unit on site in 6 weeks, the technician said, without a hint of irony. "Commissioning takes another week. So, 7 weeks to full operational status." "7 weeks?" Noah's voice rose, cracking slightly. "The basin floods in 7 hours. I need this engine running tonight. You said it's a fuel issue. Can't we just bypass the tank, run it from a jerry can, just to get the pumps moving?" The technician recoiled, as if Noah had suggested setting the building on fire. "Absolutely not. That's a liability violation. If we attempt to crank this engine with a seized pump, we could shear the timing gear or send shrapnel into the block. As a certified technician, I cannot authorize a restart on a condemned unit. It's a ticking time bomb. Sign the condemnation, order the replacement, and we can arrange for a temporary rental unit to be trucked in. Within 3 to 4 days. 3 to 4 days meant the basement was gone. It meant the archives were pulp. Noah looked at the technicians, clean and calm, protected by their corporate liability shield. They weren't there to fix the problem. They were there to manage the risk. They were useless to him. Noah turned his back on them. He walked over to the metal maintenance desk in the corner, a relic covered in layers of dust and grease. He pulled open the bottom drawer, bypassing the laminated safety sheets and digging for a ragged, oil-stained binder that hadn't been opened since the late 90s. It was the original installation log. He flipped past the yellowed commissioning sheets until he found it. A business card specifically stapled to the inside cover. The edges were frayed, and the text was typed on a typewriter. Lucas Vance, heavy diesel specialist, installation and commissioning. It was a long shot. The man might be dead. He might be in a nursing home. But Noah remembered the stories the old facility manager used to tell about Vance. A man who could time an injection pump by ear, and who regarded digital multimeters with deep suspicion. Noah pulled out his phone, his hand shaking slightly, and dialed the number. The phone rang 4 times. Then a voice answered. It wasn't a smooth corporate greeting. It was a rough, gravelly sound, like stones grinding in a cement mixer. "Vance." "Mr. Vance, this is Noah from Station 4 Municipal Pumping," Noah said, rushing the words. "You installed our Volvo TD-100 back in '94. We have a crisis." "Station 4, Vance repeated, the recognition slow but present. "That's the standby unit. Low hours. Good iron. What's the problem?" It died during a load test. Instant shutdown. No noise, no smoke. The authorized service team is here. They're claiming systemic fuel contamination, seized injection pump, total loss. They want to replace it. There was a pause on the line, heavy with judgment. Contamination? Vance asked, the word dripping with skepticism. On a closed-loop standby tank that gets polished monthly? Did they pull the injectors? No. They plugged in a laptop. They said the rail pressure variance is critical. Vance let out a short, sharp sound that might have been a laugh or a bark. Rail pressure variance on a mechanical governor? They're reading a ghost. Listen to me. Did the engine hunt for idle before it died? Did it surge? No, Noah said. It just cut, like a light switch. That's not fuel, Vance said, his voice hardening with certainty. Fuel failures are messy. They cough, they sputter, they starve. Instant death is electrical. Those boys are looking at a screen, not the machine. I'm 20 minutes out. Don't let them sign anything. And for God's sake, don't let them touch the governor. You'll come? Noah asked, relief washing over him like cold water. I'm already in the truck, Vance said. Keep the door open. The vehicle that turned into the station lot 20 minutes later didn't hum with the quiet efficiency of a hybrid service van. It announced itself with the heavy, rhythmic clatter of a mechanical diesel engine. It was a square-body service truck, the kind that had rusted out its original quarter panels a decade ago and had them replaced with diamond plate steel. It didn't have a wrap. It didn't have a logo. It was simply a tool, painted in a flat industrial gray that matched the storm clouds above. When the driver kill-switched the engine, the silence that followed felt heavy, like the pause before a judge delivers a sentence. Lucas Vance stepped out into the rain. He was a man built from the same material as the truck, weathered, sturdy, and entirely unconcerned with aesthetics. He wasn't wearing a uniform with a name tag. He was wearing a set of coveralls that had been washed 1,000 times, the fabric softened and faded to the color of old oil, yet permanently stained with a dark ghost of grease from machines long since scrapped. He didn't carry a plastic case or a laptop. In his right hand, gripped with knuckles swollen from years of turning wrenches, was a red steel toolbox. It was battered, the paint chipped away to reveal raw metal, covered in stickers from parts suppliers that had gone out of business in the 90s. He walked through the station doors, bringing the smell of the storm and old hydrocarbons with him. The contrast in the room was immediate and violent. On one side stood the two technicians, pristine in their branded polos and khakis, illuminated by the cold blue light of their screens. On the other stood Lucas, dripping wet, smelling of 15W40 and tobacco, looking at the room not as a data set, but as a physical space. The lead technician looked up from his laptop, his face twisting into a sneer of professional offense. He saw the dirty coveralls, the lack of a badge, the ancient toolbox, and he made an instant calculation. "Excuse me," he said, stepping between Lucas and the generator, using his body as a barrier. "This is a controlled work area. We are in the middle of a certified diagnostic procedure. You can't be back here. Liability." Lucas didn't stop. He didn't even slow down. He simply walked around the technician as if he were a traffic cone, setting the heavy steel toolbox onto the concrete floor with a resounding thud that echoed off the block walls. "Noah called me," Lucas said, his voice a low rumble that seemed to come from his chest rather than his throat. "Said you boys were condemning a 30-year-old engine because you don't know how to read a fuel gauge." "We aren't reading a gauge," the technician snapped, his face reddening. "We are reading the engine control unit. We have confirmed systemic contamination. This unit is dead. If you touch it, you void the chain of custody on the failure analysis." Lucas ignored him entirely. He turned his back on the screens and looked at the machine. He placed a hand on the valve cover of the TD-100. It was a gesture of respect, almost intimate, the way a doctor touches a patient's shoulder. He wasn't looking for a code. He was looking for a pulse. He leaned in, inhaling deeply near the intake manifold, then moved to the fuel tank breather. "Smell that?" Lucas asked, looking at Noah. Noah stepped closer, confused. "Smell what?" "Exactly," Lucas said. "Nothing. If you had algae bloom severe enough to seize a P7100 injection pump, this room would smell like rotten eggs and varnish. It would smell like a swamp." He unscrewed the fuel cap and waved his hand over the opening. "Smell the diesel. It's sharp. It's clean. It smells like petrochemicals, not biology." The smell is irrelevant, the technician interjected, tapping his tablet furiously. The rail pressure sensor is reading 0. The variance is 100%. The fuel is too thick to pump. It's sludge. Lucas shook his head, a small, cynical smile touching his lips. He walked over to the primary fuel filter assembly mounted on the bulkhead, a dual Raycore setup with clear plastic sight bowls at the bottom. These filters were the kidney of the engine, the first line of defense. If the fuel was contaminated, these bowls would be black with asphaltenes or cloudy with emulsified water. Lucas pulled a heavy-duty flashlight from his pocket and shone the beam directly through the clear plastic bowls. The diesel inside was a bright, translucent amber. It was perfectly clear. There wasn't a speck of sediment. There wasn't a drop of water. "Look at the glass," Lucas commanded, pointing the beam. "That fuel is cleaner than the water in your water cooler. If the pump was eating sludge, this filter would be plugged solid. You're telling me the contamination skipped the filter, skipped the lift pump, and only decided to exist inside the high-pressure sensor?" "The sensor detects a variance," the technician shouted. "It's a digital output." "The sensor is just reading 0 pressure," Lucas said, turning off the light. "That doesn't mean the fuel is bad. It just means the fuel isn't moving." Lucas wiped a smudge of dust from the side of the injection pump, his movements deliberate and slow, a stark contrast to the frantic tapping of the technicians on their glass screens. He turned to Noah, ignoring the lead technician entirely, treating him like background noise, or a nuisance alarm that needed to be silenced. "Noah, come here," Lucas said, his voice dropping into the register of a teacher addressing a student. "Forget the screen. Look at the iron. Do you know what this is?" He rested his hand on the massive, blocky component bolted to the side of the engine block. It was painted the same industrial green as the rest of the machine, but it bristled with 6 steel lines that curved up like the ribs of a skeleton. "It's the fuel pump," Noah said, stepping closer, feeling the radiant cold coming off the metal. "It's a Bosch P7100 mechanical injection pump," Lucas corrected, "geared directly to the engine timing. As long as the engine turns, this pump turns. If you put sludge into a P7100, it doesn't die quietly. It screams. It chatters. The governor fights the blockage, hunting for idle. It's a violent death." "Noah, did you hear violence?" "No," Noah said, shaking his head. "It was instant. Silence." "Exactly," Lucas said. "Instant silence isn't mechanical failure. Mechanical failure has inertia. Instant silence is a switch." The lead technician stepped forward, his face flushed. He held the tablet up like a shield. "You are oversimplifying a complex system. The ECU data is clear. The rail pressure dropped to 0 milliseconds before shutdown. The critical variance code means the pump failed to deliver pressure when commanded. The system went into protective lockout because the pump is dead." "The pump isn't dead," Lucas countered, his voice hard. "The pump is starving. Of course the pressure is 0. The sensor is reading 0 because there is no fuel entering the plunger gallery. But that's not because the fuel is bad, it's because the gate is shut." Lucas pointed a grease-stained finger at a small cylindrical component mounted at the rear of the injection pump. It had a single wire running to it, terminating in a rubber boot. "That," Lucas said, "is the fuel shutoff solenoid. Do you boys know how a solenoid works on a 1994 vintage industrial diesel?" The second technician looked up from his screen, blinking. "The ECU manages the solenoid state based on the ignition map," he recited, as if reading from a manual. "If the ECU detects a fault, it de-energizes the solenoid to protect the engine." Lucas laughed, a dry, humorless sound. "You're thinking of a modern common rail system, where the computer is the brain and the engine is the puppet. This is legacy architecture. On this engine, the solenoid is a power-to-run system. It's dumb iron. It has a heavy spring inside that wants to push the fuel rack to the off position. To run the engine, you have to hit this magnet with 24 volts of continuous electricity to pull the spring back and open the fuel rack." He turned back to Noah, driving the point home. "The computer didn't shut this engine down. The solenoid lost power. The magnet let go, the spring snapped the rack shut, and the fuel stopped instantly. The sensor is reading a variance only because it expects pressure and sees none. It's not contamination. It's an electrical phantom." "That's a theory," the lead technician scoffed, though his grip on the tablet had loosened slightly. "But the ECU says—" "I don't care what the ECU says," Lucas interrupted, his voice rising for the first time. "I care about what the circuit does. You're ready to scrap a $100,000 piece of machinery because you're trusting a sensor that's confused by a lack of voltage. You're trying to perform surgery when you should be checking the light switch. Lucas reached into his pocket and pulled out a multimeter, an old Fluke model, battered and scarred, with leads that had been taped and retaped. He didn't ask for permission. He stepped past the technician, invading the controlled work area with the unstoppable momentum of a man who knows he is right. "Let's see who's lying," Lucas muttered. "The screen or the wire?" Lucas reached for the two heavy, chrome-plated thumb latches on the side of the generator's control box. They turned with a stiff, mechanical resistance that spoke of years of disuse. With a sharp metallic clang, the hinged door swung open, exposing the nervous system of the machine. To the untrained eye, it was a chaotic jumble of colored spaghetti. But to Lucas, it was a historical document. He leaned in, his flashlight cutting through the gloom of the station, illuminating the stark difference between two eras of engineering. The original 1994 wiring was a work of art, thick, 14-gauge copper strands insulated in high-temperature rubber, laid out in neat, parallel runs held by metal loop clamps. The terminations were crimped, soldered, and heat-shrunk. It was built to survive a nuclear winter. But overlaid on top of this industrial order was the chaos of the modern retrofit. It looked like a parasitic infection. Thin, cheap 22-gauge ribbon cables were zip-tied haphazardly to the sturdy original looms. Plastic Scotch lock connectors, the mark of a lazy installer, bit into the vintage insulation like vampire teeth, stealing power for the new digital sensors. "Look at this," Lucas murmured, tracing a thick red wire with the tip of his multimeter probe. "This is the primary ignition circuit. It comes straight from the battery disconnect, through the main breaker, and feeds the run relay. It's the artery that keeps the heart beating." He touched the black probe to the chassis ground, and the red probe to the input terminal of the main relay. The multimeter let out a solid, unwavering tone. The screen displayed 25.1 volts. "Battery voltage is healthy," Lucas stated, his eyes moving downstream. "The heart has blood." The two technicians watched him with a mix of impatience and confusion. They were used to plugging a cable into a port and waiting for a software prompt. Watching a man physically trace a circuit with metal probes seemed archaic to them, like watching someone navigate by the stars instead of GPS. "You're wasting time checking the supply voltage," the lead technician sighed, checking his watch. "The ECU is powered up. We know there's power. The issue is the hydraulic failure in the pump." "The ECU has power because it has its own fused circuit," Lucas corrected, not looking up. "But the ECU doesn't open the fuel rack. The solenoid does." He moved the probe further down the line, following the thick red wire as it snaked toward the engine block. His finger stopped at a chaotic junction where the new wiring harness had been grafted onto the old system. A bundle of thin, brightly colored wires from the retrofit sensors, the very sensors that were screaming contamination, had been spliced directly into the heavy ignition wire. "Here is your crime scene," Lucas said, pointing to the splice with the probe. "When they installed your fancy monitoring system, they didn't run a new power feed. They were lazy. They tapped into the key-on power source for the fuel solenoid." He looked at Noah, who was leaning in close. "Noah, do you see this? The fuel solenoid on a TD-100 draws about 20 amps for a split second to pull the rack open, then drops to about 1 amp to hold it open. It needs a clean, unobstructed rush of current. But look what they added." Lucas gestured to the cluster of added wires. "Pressure sensors, temperature senders, the wireless gateway. They're all drawing load from this same wire. They added resistance. They added noise. They turned a fire hose into a garden sprinkler." He moved the probe past the splice, further down the line toward the solenoid connector itself. He was now checking the wire after the parasitic load of the sensors. "If the fuel is contaminated," Lucas said, his voice dropping to a whisper, "then the solenoid should still be getting power. It should be fighting to stay open. The magnet should be energized." He jammed the red probe into the back of the solenoid connector, making contact with the terminal. He looked at the multimeter screen. The technicians leaned in, expecting to see 24 volts, proving that the electrical system was fine and the mechanical pump was indeed seized. The screen read 0.00 volts. "Zero," Lucas said, the word hanging in the air like smoke. "The line is dead. There is no power reaching the solenoid. The magnet never pulled. The rack never opened." He turned to the lead technician, his expression grim. Your sensors are reading zero pressure because the engine is turned off. You didn't lose the pump. You lost the circuit. The sensor wasn't lying to you. It was just describing a ghost. But the switch is on, the technician stammered, looking at the control panel where the run light was illuminated. The panel says it's running. The panel is lying, Lucas said, holstering the multimeter. The switch is sending power, but it's not arriving. Somewhere between that splice and this plug, the circuit is broken. The wire gave up. He turned back to the chaotic splice, his eyes narrowing as he hunted for the weak link. And I bet I know exactly what failed. Lucas didn't stop at the dead reading on the multimeter. A dead wire is not an answer. It is merely a signpost pointing toward the real problem. He holstered the meter and began to physically trace the compromised circuit, his hands moving with the tactile certainty of a surgeon probing for a bullet. He followed the red wire from the chaotic splice, tracking it as it disappeared behind the massive, cast-iron bulk of the starter motor. It was a dark, greasy void where visual inspection was impossible. This was the part of the job that tablets and diagnostic dongles could never replicate, the part that required knuckles, sweat, and the willingness to bleed slightly for the machine. He jammed his arm into the tight gap between the engine block and the frame rail, his face pressed against the cold metal of the oil pan. He wasn't looking with his eyes. He was seeing with his fingers. He felt the rigid loom of the original harness, the brittle plastic of the conduit, and then, deep in the shadows, he felt an anomaly. It was a lump in the line, a bulbous, irregular mass wrapped in layers of petrified electrical tape that had hardened into a shell over 30 years of heat cycles. "Got you," Lucas grunted, the sound echoing in the silent station. He pulled his arm back, dragging a loop of the harness into the light. The lump was coated in a thick paste of oil and road grime, indistinguishable from the rest of the engine to the untrained eye. To the technicians, it looked like just another dirty wire. To Lucas, it was a time capsule. He pulled a pocket knife from his coveralls, the blade worn thin from years of sharpening, and carefully sliced through the fossilized tape. It came away in dry, cracking flakes, falling to the floor like black snow. Beneath the grime lay a translucent white plastic cylinder, an inline fuse holder of a vintage that hadn't been manufactured since the late 90s. It was a relic of the original installation, a safety redundancy that had been buried and forgotten by 3 decades of maintenance crews. Lucas gripped the two halves of the holder and twisted. They fought him for a moment, the plastic threads seized by time, before yielding with a sharp snap. He pulled the halves apart. A small glass tube fell into his grease-stained palm. He held it up to the harsh fluorescent light, squinting at the tiny metal filament suspended inside the glass. "Look closely," Lucas commanded, motioning for the lead technician to step forward. The young man hesitated, then leaned in, his eyes leaving his tablet for the first time. "It's blown," the technician said, stating the obvious. "So there was a short circuit. The solenoid failed." "No," Lucas corrected, his voice sharp. "If there was a short, if the solenoid had seized and spiked the amperage, this glass would be black. The filament would have vaporized instantly in a flash of silver. That's a violent failure." He tapped the glass with a dirty fingernail. "This glass is clear. The filament isn't vaporized, it's just broken. It sagged and separated. Do you know what that means?" The technician stayed silent, staring at the tiny, broken wire. "It means fatigue," Lucas said. "This is a 20-amp fuse. It's been sitting here for 30 years, carrying the current for that heavy solenoid. It heats up, it cools down. It was tired. It didn't blow because of a spike. It blew because you boys tapped 5 amps of continuous load onto a circuit that was already walking the edge. It just gave up." The realization hit the room with physical weight. The catastrophic failure wasn't a seized pump. It wasn't algae. It wasn't a $180,000 disaster. It was a 50-cent piece of wire that had finally melted under the strain of modern incompetence. "When this fuse popped," Lucas continued, his voice low and intense, "power to the solenoid cut instantly. The spring slammed the fuel rack shut. That's your instant silence. And because your fancy sensors were stealing power from the same line, they lost their reference voltage at the exact same moment. They didn't read zero pressure because the pump failed. They read zero because they went blind. Your contamination error was just the computer screaming because someone turned off the lights." The technician stood frozen. The glossy PDF on the laptop screen, with its 6-figure quote and dire warnings, suddenly looked ridiculous, a monument to arrogance. Noah looked from the fuse to the technicians, his expression shifting from fear to a cold, simmering anger. Lucas didn't wait for an apology. He reached into his battered red toolbox and pulled out a small, clear plastic organizer. He selected a fresh 20-amp ceramic fuse, a modern, heavy-duty upgrade designed to handle the heat. He cleaned the contacts of the holder with a strip of emery cloth until the brass shone like gold. He inserted the new fuse, felt the satisfying click of the retention clips, and screwed the holder back together. He wrapped it in fresh, high-quality tape, sealing it against the moisture of the storm. "The circuit is restored," Lucas said, standing up and wiping his hands on a rag. "The heart has blood again. Now, let's see if the patient wakes up." Lucas moved to the side of the engine block, ignoring the technicians who were now watching him with a mixture of skepticism and anxiety. He didn't reach for a keyboard or a diagnostic port. He reached for the manual priming plunger, located on the side of the lift pump. It was a simple, mechanical device, a small brass piston that allowed a human hand to do the work of the engine. He unscrewed the knurled cap and began to pump. Click whoosh, click whoosh. The sound was small in the quiet room, but it was the sound of life returning. Lucas pumped steadily, his eyes fixed on the clear bowl of the Raycor filter. With every stroke, he was forcing fresh diesel through the lines, pushing it past the now open solenoid and into the gallery of the injection pump. He wasn't looking for a digital ready signal. He was waiting for a physical sensation. After 20 strokes, the plunger stiffened. The resistance increased sharply. The fuel was solid. The air was gone. The gallery was full. "Noah," Lucas said, his voice calm but commanding over the relentless drumming of the rain on the roof. "Get to the control panel. Reset the alarm." Noah moved to the panel, his fingers trembling slightly. He pressed the reset button. The red shutdown light blinked off, replaced by a steady amber ready. "But the contamination," the lead technician started, his voice weak but persistent. "If the pump is seized, cranking it will shear the drive gear. You're taking a massive risk. Pushing fuel into a locked plunger could blow the housing." "The pump isn't seized," Lucas said, locking the priming plunger back down and wiping a streak of diesel from his thumb. "And the only risk here is that you're about to look very foolish. Noah, hit the button." Noah pressed the green start button. The heavy-duty starter motor engaged with a high-pitched mechanical whine, turning the massive flywheel. Whirr, whirr. The engine turned over exactly twice, the compression fighting the starter for a split second. Then, the world changed. K-A-B-O-O-M. The TD-100 didn't just start. It detonated into life. The sudden compression of 6 10-liter cylinders shook the concrete floor beneath their feet. A puff of gray smoke shot from the exhaust stack, the sign of cold fuel hitting hot compression, and then cleared instantly as the combustion stabilized. The engine settled immediately into a deep, rhythmic, chest-thumping idle at 800 RPM. It wasn't the high-pitched whine of a modern high-speed turbine. It was the slow, confident heartbeat of heavy iron. Thrum, 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 thrum. The sound filled the station, drowning out the storm, drowning out the technicians' protests, drowning out the fear of the rising water. It was the sound of competence. It was the sound of a machine that had been ready to run all along. Lucas stepped back, crossing his arms, watching the belt drive spin with a blur of motion. He looked at the technicians. They were staring at their tablets in absolute disbelief. The screens, which had been washing the room in red alarm lights just moments ago, suddenly flashed green. "Look at that!" Lucas shouted over the roar of the engine. "Code P0087 is gone. Code P0093 is gone. Your critical variance just vanished." The lead technician tapped his screen furiously, trying to understand the data. "The pressure. It's normal. It's reading 45 psi at the rail. The variance is 0. The injectors are firing perfect." "Of course it's 0, Lucas yelled, leaning in so the technician could hear him. "Because the solenoid is open. The fuel is flowing. You didn't fix anything. The engine fixed itself the moment we gave it electricity." The generator's output breaker clunked shut automatically, and the hum of the facility's main pumps kicked in. The vibration in the floor changed pitch as the load came on. The TD-100 didn't falter. It took the load without a stumble, the mechanical governor adding just enough fuel to maintain the frequency. It was doing exactly what it had been built to do 30 years ago. Lucas began to pack his tools. He wiped the multimeter down and placed it back in its case. He closed the heavy steel toolbox with a finality that signaled the end of the lesson. "You were ready to scrap this unit," Lucas said, walking up to the technicians. "You wrote a report, used big words to hide a simple truth. And all you had was a blown fuse caused by your own sloppy wiring." He pointed a calloused finger at the lead technician's chest. "A sensor is a tool, son. It is not a god. It tells you what it sees, but it doesn't tell you why. You saw zero pressure and assumed the pump was broken. You never stopped to ask if the pump was just turned off. Next time, before you condemn a piece of legacy iron because a computer told you to, try getting your hands dirty. Check the power, smell the fuel, read the machine, not the tablet." He turned to Noah, who was looking at the running engine with the expression of a man who had just witnessed a miracle. "She's good for another 10 years, Noah. Just keep the oil changed and keep the firmware updates away from her." Lucas picked up his toolbox and walked toward the door. The technicians didn't say a word. They couldn't. The deafening, beautiful roar of the Volvo TD-100 was the only argument that mattered. The storm raged on outside, but inside Station 4, the lights were bright and the pumps were churning, pushing the floodwaters back into the river. Noah picked up the glossy, 6-figure replacement quote from the desk, crumpled it into a tight ball, and tossed it into the trash bin. The dead engine hummed a steady, victorious rhythm in the background. If you believe that true expertise is measured by results, not expensive reports, make sure you subscribe. We'll see you on the next job.